light from a source, comma, if it enters from medium 1 into medium 2, its speed increases by 25%. Its speed increases by 25%. However, as it travels from medium 1 to medium 3, its speed reduces by 25%. The same light is meant to fall on the arrangement shown in the figure at an angle of incidence, shown in the figure at an angle of incidence sine inverse of 5/6. Find the angle of refraction in medium 1. Sine inverse of 5/6. This is the angle of incidence on the second medium. Angle of refraction in the first medium is to be calculated. So finally, the ray will be emerging at angle of refraction for this particular part. You have to calculate the angle of refraction for this. Only you have to make the use of Snell's law. So from the first lines, can you tell me what is the data you have to enter there? The first line is extremely important. Light from a source, if it enters from medium 1 to medium 2, its speed increases by 25%. So can I make a statement here that V1 is the velocity in a medium 1? V1 is representing velocity in medium 1. When it is traveling from medium 1 to medium 2, velocity increases. V2 is equal to 1.25 times V1. Now again you will have a question from where the sir is talking about 1.25. Have you got it? Everyone has got it now? And another statement it is made, however, as it travels from medium 1 to medium 3, the velocity reduces by 25%. So can I write down the relation here that value of V3 is equal to 0.75 times V1? Or should I prove it to you how it is coming out to be 0.75? Getting everyone? It is 100 minus of 25 upon 100. So 75 by 100 means 0.75. Now, if you can write down in that manner, that is not a problem, but it increases the time. You can rewrite this as V3 is equal to V1 minus of V1 into 25 divided by 100. So you will be having 100 V1 minus of 25 V1 divided by 100. So you will be getting this answer as 0.75 V1 upon 100. Sorry, 0.75. Already divided. So can you work with this? The confusing part of that, I have already given you the solution of this. Just you have to use the Snell's law and see that you are getting the answer for angle of refraction in the first medium. Snell's law will be applicable only at the boundaries. Okay? So I can put it down. The refractive index, is it given to me? Angle of incidence is given. What will be the angle of refraction? So how are the velocities? Velocities, if you look at, V2 is given to you as 1.25. V2 is given to you as 1.25 times V1. V3 is given to you as equal to 0.75 times V1. And here you will be having the relation. So what is V2 by V1? So you are able to aware, you are aware of this part. Refractive index of second medium with respect to first is V1 by V2. So this will be refractive index of 2 is coming here. So I will be having 1 with respect to 2. Able to get this? This is the basic formula. Refractive index of second medium with respect to first. Second medium with respect to the first. Right? So that ratio has been given to you, V1 by V2 here. Or refractive index of 1 with respect to 2 is V2 by V1. So can you write down here that V2 by V1 is refractive index of first medium with respect to second. That is given to me as V2 by V1. That is equal to 0.75. So which medium will be more denser and which one will be the rarer? Now, about the 1 and 2 we are talking now. About 1 and 2. स्पीड जिसका ज्यादा रहता है वो रेयरर रहता है, स्पीड जिसका कम रहता है वो डेंसर रहता है. इसमें स्पीड आपका 0.75 दिया है V2 का. V2 का स्पीड कितना दिया है? सॉरी 1.25 है. सो V2 by V1, सो यहां का जो रिफ्रैक्टिव इंडेक्स रहेगा वो μ2 रहेगा, यहां का μ1 रहेगा. सो यू विल बी एबल टू हैव μ2 by μ1. दिस विल बी μ1 by μ2. Am I right? So μ1 will be greater than μ2. So this is a denser medium. This is a rarer medium. Medium? Right, right. So mu2 by mu1 we are looking at now. So we can use this relation here and put it down. Mu1 into V1 is equal to mu2 multiplied by V2. Forget about that part. Can I write down like this? Now, if you are writing it mu1 V1 is equal to mu2 V2, so V1 by V2 का रेशियो कितना है आपको? V1 by V2 का रेशियो कितना आया? This is V1, so you will be able to put it down as V2 by V1 ratio here. V2 by V1 ratio is 1.25, so I will be having mu1 is equal to 1.25 times mu2. Check it out. Check out whether I'll be getting this or not. Right? What about the second and third? Second और third के लिए क्या relation रहेगा? यानी third और first के लिए आएगा ना वो. तो V3 by V1 is equal to 0.75. What is V3 by V1 as per this definition? Refractive index of 1 with respect to 2 is above. So you will be having here refractive index of 1 with respect to 3. Right? So you will be able to write down refractive index of 1 upon refractive index of 3, that is equal to 0.75. So this is my first relation. This is my second relation. Now light is traveling from second medium to the third medium, right? ये जो है इसमें second to the third travel हो रहा है ना light. Able to get it? Second to third. तो second to third के लिए हम क्या लिखेंगे? Refractive index of second medium multiplied by sine of angle of incidence is equal to refractive index of third multiplied by sine of angle of refraction. So refractive index of second and third relation is not known, so I will put it down here mu2 into sine of. You are having here sine inverse of 5 by 6 is equal to mu3 into sine of r. ओके ठीक है, तो यहां पर हमें आंसर क्या मिलेगा? साइन ऑफ साइन इनवर्स विल बी गेटिंग कैंसल्ड, सो यू विल बी हैविंग mu2 into 5 by 6 is equal to mu3 into sine of r. Am I right? तो ये एंगल ऑफ रिफ्रैक्शन आपका कौन से इसमें है? सेकेंड में रहेगा या थर्ड में रहेगा? बिकॉज वी आर राइटिंग विथ रिस्पेक्ट टू mu3, राइट? तो दैट इज द रिलेशन. ये हमारा mu1 है, ये हमारा mu3 है, यानी यहां का एंगल ऑफ रिफ्रैक्शन हम देख रहे हैं ना. तो उन्होंने आपको प्रॉब्लम में क्या दिया है? रीड द प्रॉब्लम. प्रॉब्लम में उन्होंने ये कहा था, light from a source, if it enters from medium 1 into medium 2, its speed increases by 25%. However, as it travels from medium 1 to medium 3, its speed reduces by 25% at an angle of incidence of 5 by 6 on a medium 2 बोला है. Medium 2. So actually I should have changed the figure a little bit, क्योंकि यहां पर 3 लेयर्स मैंने बताए हैं, बट मीडियम 2 का जो बाउंड्री है वहां पर वो रे आएगा. यानी जो रे आपको दिया हुआ है, इट विल नॉट बी इंसिडेंट एट दिस पर्टिकुलर पॉइंट, इट विल बी इंसिडेंट ऑन द बाउंड्री ऑफ सेकेंड एंड थर्ड. सेकेंड, थर्ड एंड 1. तो ये बाउंड्री जो रहेगा यहां पर वो इंसिडेंट हो रहा है at an angle of incidence that is given to you as sine inverse of 5/6. अब यूज करके देखोगे तो अब सिंपल हो जाएगा, μ2 इंटू साइन आई विल बी इक्वल टू μ3 इंटू साइन ऑफ आर. इसमें अभी साइन ऑफ आर आएगा, तो यू आर हैविंग दैट पार्ट μ2 इंटू साइन आई इज इक्वल टू μ2 इंटू साइन आर. दिस इज एक्चुअली द सेकेंड थर्ड बाउंड्री, and you are having this as the third and the first boundary. तो दो बाउंड्रीज के लिए दिया है, तो you are able to get here the angle of refraction. Whatever is the angle of refraction, let us put it down like this, that this will be the angle of refraction here. That angle of refraction would be taken here by this equation, and that will become the angle of incidence at this point. At this point, this will be the angle of incidence. Whatever is the angle of refraction here, same will become the angle of incidence here. You need to understand, whenever you are having the layers, एक का angle of refraction, दूसरे का angle of incidence बनता है. So in that particular case, you will be using for the third part, μ3 into sine of r is equal to μ1 into sine of E. I am using the different because it will be then changing the angle here. So if it is passing in a different medium, suppose like this, I am just giving you an example, then this will be E. So I am using it for the third and the first boundary. So now you are having here μ3 into sine of R. So sine of R will be μ2 by μ3. This μ3, I am bringing it down, multiplied by 5/6 is equal to μ1 into sine of E. So you will find that μ3 is getting cancelled. You will be having the relation μ2 and μ1. μ2 and μ1 you have already written here. That is how much? μ1 is equal to 1.25. So you will be having here μ2 into 5/6 but is equal to μ1. Value of μ1 will be 1.25 times μ2. 1.25 times μ2 multiplied by sine of E. So this μ2 is getting cancelled here, and you will be having this as 5/4. 1.25 can be written as 5 divided by 4. So I will be having 5 also getting cancelled. 6 is producing 3 here, and this is producing 2. So you will be having sine of E. Sine of E will be equal to 2/3. So value of E will be equal to sine inverse of 2/3. So if you are having any question, you can raise it. I'll explain it again. There are two aspects in it. One is the relation of velocity, and second one is the application of Snell's law. So if you use both of them, you are able to get the solution in this manner. Three different mediums are given to you. This is having the refractive index μ2. This will be having refractive index μ3, and this is having refractive index μ1. You are asked to calculate when the light emerges out here, what will be the angle of refraction at this particular point. ये आपको पूछा है. आपको पहले क्या दिया है? When the light travels from first medium into second, am I right? First medium into second. So the speed increases by. So V2 is taken as equal to 1.25 times V1. Can I write down like this? Now, general formula for refractive index of any medium with respect to air, we put it down velocity in air upon velocity in medium. So if I am writing refractive index of second with respect to first, it will be velocity in first upon velocity in second. Am I right? So can I write down this relation as V1 upon V2 will be equal to refractive index of second with respect to first, that is equal to V1 upon V2, so it is 1 upon 1.25. 1 upon 1.25 is 1 upon 5 by 4, so this is giving me 4 by 5. 1 और 2 का रिलेशन है उसमें. ठीक है यहां तक? अभी इसमें क्या नहीं समझ में आया बताइए. अब उसके साथ कंपेयर मत कीजिए. दिस इज अ वेरी बैड थिंग बिकॉज एक्चुअली व्हाट इज हैपनिंग, वो अलग कंसेप्ट से लिया है, अभी ये अलग कंसेप्ट से ले रहा हूं. सो इफ यू लॉस्ट इनटू द नंबर्स कि वहां पर तो V1 by V2 नहीं था, वहां पर तो V2 by V1 था, मैंने देखा भी नहीं है, then it will be different. You wanted me to solve it again, I am solving it again. तो इसमें क्या नहीं समझा, मैं वही पूछ रहा हूं आपको. 1 point वो कैसे आया? यहां लिखा है ना V2 is equal to 1.25 times V1. So what will be V1 upon V2? No, it is 1 upon 1.25. ये लिखा है ना यहाँ पे V2 is equal to 1.25 times V1. So if I bring V2 here and 1.25 here, I will be having V1 by V2 as 1.25, 1 upon 1.25. Okay? So I am having V1 by V2 ratio 4 by 5. I am having solved, all that solved. 4 by 5 is the answer here. Okay, so I am calculating for this relation because it was given to you that velocity in second medium is increasing by 25% as compared to the first medium. When the light is traveling from first to the second, velocity increases by 25%. That is why V2 is equal to 1.25 V1 is written. But when the light travels from medium 1 to medium 3, it becomes 25% is reduced. So what will be the relation there? What will be the relation? Light is traveling from medium 1 to medium 3. So V3 will be equal to 0.75 times V1. Reduced by 25%, matlab it will become 75%. Able to get this? So this step we have written here. Now, I will be writing here V3 upon V1 is equal to 0.75. That will be taken as equal to how much? तो यहां पर हम कैसे करते हैं? A यहां पर है तो ये A ऊपर चला जाता है. So this will be refractive index of 1 with respect to refractive index of 3. That is refractive index of 1 with respect to 3. Got it? अभी कोई तकलीफ नहीं यहां तक. अभी आप बाउंड्री ले लीजिए ये वाला. इस बाउंड्री के लिए आपका फॉर्मूला क्या रहेगा? μ2 into sine of angle of incidence is equal to μ3 into sine of r. So μ2 will be kept as it is, and here sine of, you are having the angle sine inverse of 5 by 6 that will be taken here is equal to mu 3 into sine of r. Sine of sine inverse will be getting cancelled. You will be having mu 2 into 5 by 6 is equal to mu 3 multiplied by sine of r. This is the first thing, that the Snell's law had been applied to this second third boundary. सेकेंड थर्ड बाउंड्री के लिए मैंने स्नेल्स लॉ अप्लाई किया यहां पे और ये रिलेशन लेकर आया. स्नेल्स लॉ इज ऑलवेज टेकन एज refractive index multiplied by sine of angle is equal to refractive index in the other medium into the sine in that particular part. That I have got it. Once I have got this, I'll apply it to the boundary 3 and 1. This is boundary 3 and 1. So ये जो 3 and 1 boundary है, इसको अगर मैं apply कर देता हूं, तो I will be having mu 3 multiplied by sine of r is equal to mu 1 into sine of emergence. और यही दिखाने के लिए I have told you this part, that this is actually expected, but you are able to see that the ray is suppose bending onto this side. Then this is representing to you angle r, and this angle of incidence will be also equal to angle r. And then you will be having here this as the angle of emergence. ठीक है यहां तक. Now substitute the value of sin r from this thing. So you will be having mu 3 multiplied by sin r, that is mu 2 upon mu 3 multiplied by 5 by 6 is equal to mu 1 into sine of e. So mu 3 factor is getting cancelled. You will be having mu 2 5 by 6. So I can have mu 2 upon mu 1 multiplied by 5 by 6 is equal to sine of angle of emergence. Now mu 2 by mu 1, how much it is? Mu 2 by mu 1, ये देखिए यहाँ पर निकाला है हमने. Mu 2 by mu 1, this is actually 4 by 5. This is the meaning mu 2 upon mu 1. Mu of second with respect to first is mu 2 by mu 1. यहाँ पर value वो डाल देते हैं, तो you will be having 4 by 5 multiplied by 5 by 6 is equal to sine of e. So factor 5 is getting cancelled, 4 is producing 2, this is producing 3. So angle of emergence will be sine inverse of 2 by 3. अब ठीक है. सेम आंसर है दोनों तरफ. Now actually what is happening, देखिए I'll tell you the basic now. If I give you a problem where a formula is known and you are asked to make only the substitution and get the answer, you are ready to get it immediately. For example, if I tell you that mass of the body is 1 kilogram, speed of the body is 10 meter per second, what is the kinetic energy? निकाल पाओगे ना? All of you will be able to calculate. But instead of giving you the problem on kinetic energy directly, if I start framing the question in such a manner that I am bringing in conservation of energy, I am bringing in conversion of energy, and finally it is getting converted into the kinetic energy, then you will get stuck to it. Because there you need the application. What we are learning here is only the application part. It's easy to learn the theory part, because theory part will not be changing. It will be remaining the same. But if you try to use only the same formulae, it will not give you the answer. Now, in this particular case, we are making the use of two concepts. One, what is refractive index? refractive index of a medium with respect to another medium. A refractive index of glass with respect to water is refractive index of glass upon refractive index of water, and that is equal to velocity in water upon velocity in glass. ये concept को हम use कर रहे हैं. And second concept we are using is actually the Snell's law, applied at two boundaries, separating the second and the third boundary and third and the first boundary. So there are two different applications applied across the boundary. That is why you are finding it difficult to get connected. And the problem maker has made it more complicated by giving that when the light is traveling from first medium to the second medium, the velocity is increasing by 25%. So that is how the problems are there. You cannot say that we will not attempt it. You have to attempt it. You have to understand it. And this application part will help you out. Okay? So this is at a relatively higher end, I can tell you. But when you handle such questions, it gives you the confidence of the lower level question. Okay? And now what is the status of your mind? Your status of mind is, इसके पहले वाला जो problem दिया था, the first one earlier to that, you might have found it difficult. After getting a solution, you find it at easier one. Now, after looking at this problem, you are surely making it difficult. But after explaining, then you start realizing, no, itna bhi difficult nahi hai. So that is what the application skills are required for the competitive exam. Okay? So I'll take a simple one so that you can understand it. Take this as a problem. This is a simple one. You should get the answer now. But it all depends on your skills. Monochromatic light falls at an angle of incidence I, falls at an angle of incidence I on a slab of a transparent material with refractive index mu. What should be the relation between I and mu, so that reflected and refracted light, are mutually perpendicular. You want me to repeat some part? You can ask me. कहाँ से repeat करना है बता दीजिए. What should be the relation between I and mu so that the reflected and refracted rays are mutually perpendicular? So monochromatic light falls at an angle of incidence I on a slab of transparent material with refractive index mu. There is no refractive index of a medium here. A transparent glass slab has been given. That is what I am trying to tell you. You just get connected with what you have seen earlier. A monochromatic light falls at an angle of incidence I on a transparent material with refractive index mu, right? So let us consider that we are having a slab of a transparent material This is a slab. Of a transparent material. And on this, the ray of light is falling like this. At an angle of incidence I, you are having the refractive index mu. You are asked to find out the relation between. It's a relation between I and mu. Relation between I and u, mu. Mu is equal to, कैसे आया? Loudly. कैसे 90 माइनस आया, कैसे आया? So आपको प्रॉब्लम में क्या दिया है? The right, but what is given to you in the problem that this is representing the reflected ray. The angle of reflection here will be equal to I, and the refracted ray will be making an angle of, this is refracted ray, it will be making an angle of 90 degree here. This is 90 degree. So what you will have here, I plus 90 plus, what you will have? I plus 90 or simply one I will be there. I plus 90 plus R is equal to 180. ये एंगल देखिए यहां से यहां तक का कितना रहेगा? ये एंगल कितना रहेगा? Angle of reflection will be equal to angle of incidence. यहां पर एक रे रिफ्लेक्ट हो रहा है और दूसरा रे रिफ्रैक्ट हो रहा है, और रिफ्लेक्टेड रे और रिफ्रैक्टेड रे के बीच में जो एंगल है वो 90 डिग्री का है. अगर रिफ्लेक्टेड और रिफ्रैक्टेड रे के बीच में एंगल 90 का है तो एंगल R, दिस इज एंगल ऑफ रिफ्लेक्शन, इक्वल टू द एंगल ऑफ इंसिडेंस. तो ये जो वर्टिकल लाइन आपने निकाला है, ये एंगल यहां से यहां तक कितना रहेगा? I plus 90 plus angle of refraction is equal to 180. Come on, say yes or no. So if this is so you will be having 90, producing 90 here. So angle of refraction will be taken as 90 minus of I. Now refractive index of the slab will be taken as equal to whatever slab is there. Slab, I'll say, with respect to the initial part, will be taken as equal to how much? Sine of I upon sine of R. What is sine of R? It will be taken as sine of I divided by sine of 90 minus I. So are you aware of what is sine of 90 minus I? So it will be taken as cos I. So if it is taken as cos I, you will be having sine of I divided by cos I. So in that case, you will be able to have tan I. So tan of angle of incidence will be equal to refractive index of the slab of the material. This is the relation between the angle of incidence and refractive index. Got that part? ये आ रहा है अभी ख्याल में? Any questions here? Okay. Now write down a problem. If angle of refraction is angle of incidence by 2, find refractive index. Find refractive index. Okay, so we will be having here refractive index is equal to sin I upon sin R. So you will be able to write down sin I divided by sin of I by 2. Right? So how it is 2? Your angle of refraction is taken as equal to I by 2. So you can have here sin of R is equal to sin of I by 2. This is like this. Why 2 should go up? Why 2 should go up? It is inside, it's an angle. That is why it cannot be 2. Now for that you require some knowledge of trigonometry. So are you aware of the formula here? Sin of A plus B. Sin A cos B plus cos A sin B. Right? Now what will be sin of 2 theta? Sin 2 theta can be written as theta plus theta. लिख सकते हैं ना? तो sin A plus B जो लिखा है उसके जगह theta plus theta लिख दो and see what you are getting on the right hand side. So it will be sin theta cos theta plus cos theta sin theta. So I can put it down to sin theta cos theta. Right? So what will be sin of I? Sin of I will be 2 sin of I by 2 cos of I by 2. So if you substitute it here, you will be able to have 2 sin of I by 2 cos of I by 2 divided by sin of I by 2. The factor sin I by 2 is getting now cancelled. You will be having here this to be taken as mu upon 2 is equal to cos of I by 2. So angle of incidence, or you can write down here the value of mu. हमको mu निकालने को बोला है तो you can put it as 2 cos of I by 2 will be the answer. Refractive index पूछा था ना आपको. This will be the answer. Or you can ask for angle of incidence. तो angle of incidence निकालना है तो I will be taken as 2 cos inverse of mu by 2. अगर इसको मैं डिवाइड कर देता हूं हाफ से तो you will be having R is equal to I by 2 is equal to cos inverse of mu by 2. तो एंगल ऑफ रिफ्रैक्शन का ये एक आंसर हो सकता है, एंगल ऑफ इंसिडेंस का आंसर हो सकता है, और यू कैन हैव द रिफ्रैक्टिव इंडेक्स म्यू 2 cos of I by 2. Got this now? If you have some difficulty, you can ask me. Done? Sine A plus B and sine, are they different? No, they are the same formula. Instead of writing A and B, you can take it as theta plus theta. What is theta plus theta? So if you substitute here A theta and B theta, you will be having sine theta cos theta plus cos theta sine theta. So you get it as 2 sine theta cos theta. So it's the same formula, only written in a different format so that you can understand it, how it is coming. हो गया? Write down. In a tank, 4 centimeter thick layer of water. In a tank, 4 centimeter thick layer of water in a bracket, refractive index of water is 4/3. Floats on a 6 centimeter thick layer of 6 centimeter thick layer of an organic liquid. Refractive index 1.48. Refractive index 1.48. Viewing at normal incidence, viewing at the normal incidence, you are looking from the top, viewing downward, viewing at a normal incidence, how far below the water surface, does the bottom of the tank appears to be? Does the bottom of the tank appears to be? I'll talk about it. And what will be the effective refractive index? What will be the effective refractive index? No, it will have. I'll tell you reason. Now, if you had been to any swimming tank, you find that the base of the tank appears to you to be elevated upward. And therefore, they put down the boards which mention that it is much more deeper, 10 meter deeper, 12 meter deeper, they mention that. Actually, if you look from outside the swimming tank, it appears to you as hardly 5 meter deep. There you can think that if you enter into the water tank, you will be able to survive because height is 5 feet 6 inches, 5 feet 8 inches, so you feel that you will be above the water. But when you enter it, actual depth is always going to be there of around 10 meter or 12 meter where you are likely to sink inside. So that is how the things are happening because of refraction. So we are having a problem here where we are given a 4 centimeter thick layer of water is floating on 6 centimeter thick layer of organic liquid, and how far below the water surface does the bottom of the tank appears is the question asked to you. The moment I'll give you the solution, you will say that yes, this part was known to you. Should I? or you are able to do something. Yesterday's last topic. We were having the 2 layers of liquid. What is that? Answer किसका दे रहे हो? Apparent depth. Apparent depth is different. Last topic of yesterday's lecture. There was a liquid whose depth was D1, another liquid whose depth was D2. D1 was having the refractive index mu1, another one was having refractive index mu2. The apparent depth was calculated up to the image 2. 7 point. This is more correct. Exactly कितना आ रहा है मुझे पता नहीं है, because the calculation how do you do that is all dependent on that. It is 7.05 mentioned here. 05. चलो बताइए वाटर कहां पर है? टॉप पर है. वाटर टॉप पर है. What is the refractive index? 4/3 given to you. और डेप्थ कितना दिया है? 4 centimeter है. So you will be able to show here that this is 4 centimeter depth for the water. This is representing your D1 is equal to 4 centimeter, and refractive index of the first part is given to you as 4/3. Then the second part is D2, organic liquid है यहाँ पर. This is some organic liquid. इसका डेप्थ कितना दिया है? कितना इसका? 6 centimeter. So D2 is taken as equal to 6 centimeter. And refractive index of the second part of the liquid is 1.48. Right? You are observing from the top. This is a top view that you are able to have. Viewing is done from the top, normal incidence. Then the bottom will appear to you to be shifted upward. इसके लिए कलम ने फॉर्मूला लिखा था, D apparent will be equal to D1 upon mu1 plus D2 upon mu2. So if you look at that, 4 divided by 4/3 plus D2, that is taken as 6 divided by 1.48. So you will be able to have 4 getting cancelled here. This is producing 3 plus you are having 6 upon 1.48. So it will be to be calculated. If you take it as 5, 1.5, then it will be 4. 3 plus 4 will be 7. So you can calculate that value and put down the answer here. So it will not be appearing to you to the depth of 10 centimeter. It will appear to you to the depth of, are you able to get it? 7 centimeter ही depth आपको appear होगा. Got it? Yeah. But because of the mixture of 2 liquids, it will not be working in that simple manner. The bottom where the light will be coming from the bottom will be traveling from one medium to the second medium into the air. There will be a refraction that will be taking place. Because of mixing of liquid, this is happening. This is the first part of the question. Second part क्या था? So refractive index effective निकालना है आपको. You can divide it 1.48 से, तो आपको पता चलेगा कैसे आता है डिवीजन. अगर मैं इसको 1.5 लेता हूं तो ये 4 हो जाएगा approximately. So 7 will be the answer closer to it. It will be greater than 7. It will not be exactly 7. Slightly greater than 7 will be there. दूसरा पार्ट बोला था effective refractive index निकालना है, तो you will be having D actual upon D apparent. So D actual कितना था? D1 plus D2 था, divided by D1 upon mu1 plus D2 upon mu2. Now this part we have calculated. D1 plus D2 will be 10 centimeter divided by 7 centimeter. So that will be giving you the answer as 1 point आ जाएगा Getting it? 1.428. Have you seen this formula? अब ये क्यों नहीं आया फिर? Before you see the solution, what you were thinking? This is more difficult. समझ में नहीं आ रहा था क्या करना है, कैसे करना है. And after the solution, it's the smallest solution you are having it. So you start feeling easy है ये, difficult नहीं है. So length of the solution does matter. If it is small, you start feeling that it is easier. हो गया? Write down. An observer looks at an object. An observer looks at an object. An observer looks at an object kept at a distance of 30 centimeter in air. If a rectangular glass plate of refractive index 1.5 is placed between the observer and the object, with its thickness along the line of observation, comma, the object appears to the observer at a distance of 25 centimeter. Find the thickness of the glass plate. Again, this is a question related to the content that we have discussed yesterday. 15th. I don't remember the number. You can tell me the formula, I'll be. You may be right. Very good. You have to make the use of normal shift formula. So you were looking, actual the depth is 30 centimeter, and when you are looking from normal vision, it is appearing to you 25 centimeter. So what is the normal shift? 5 centimeter. So normal shift का formula use करो, thickness निकाल लो. Yes, it is correct, 15 centimeter. So what is the formula for normal shift? T into 1 minus 1 by mu. Substitute the value of mu as 1.5, shift as 5 centimeter, solve it, you will be able to get the answer for the thickness. The thickness will turn out to be equal to, RI sabko 15 centimeter. How many of you have got the answer? Please raise the hands. RI. Now have you seen the bird and fish problem? Have you seen that? So do you remember when a fish is observing the bird, the height of the bird appears to the fish as greater than the actual height or lesser than the actual height? Greater than the actual height. So what will be the height at which it appears? H apparent kitna rahega? It will be greater than H actual. So by what factor? It is a refractive index. Factor will be refractive index. Always it is taken as H apparent upon H actual. For the fish, that will be equal to refractive index. So H will be equal to, H apparent will be equal to H actual multiplied by refractive index. Right? So on that part, there is a problem. Just try to answer it. It's simple. A fish rising vertically to the surface of water, a fish rising vertically to the surface of water in a lake uniformly at the rate of 3 meter per second observes a kingfisher bird diving vertically downward towards the water at the rate of 9 meter per second vertically above it. 9 meter per second vertically above it. If the refractive index of water is 4 by 3, if the refractive index of the water is 4 by 3, find actual velocity of the dive of the bird. Find actual velocity of the dive of the bird. 12. Actually, let us consider that you are having a fish here. The actual depth of the fish inside the water is taken as x, and you are having the actual height of the bird as seen, actually the bird that is flying here, we are taking it as equal to y. But how does the fish look at the bird? Does the fish feels that the bird is closer or away? So apparently you will be able to see that the bird will appear to the fish at this height. So this height is taken as equal to refractive index multiplied by y. So height, actual height seen by the fish will be equal to x plus mu multiplied by y. This is the first equation you should be able to understand. If you are having any question, you can ask me. We have seen the concept yesterday. I am directly writing that relation accordingly. Quick question hai? Fish is at the actual depth x and bird is at an actual height h. Y, sorry. Y is the height of the bird above the sea level. But when the fish looks at the bird from inside the water, it feels that the height of the bird is more. So by what factor it is more? It is mu multiplied by y. That factor, it appears to the fish, the bird is at a greater height. So the actual distance between the two felt by the fish will be taken as the height h is equal to x plus mu multiplied by y. Okay? Loudly, please. I am not able to hear you, please. Vertical distance only will be taken because in the problem it is mentioning that it's a vertical distance. You can look at the problem, you will be able to get the answer there. Problem में दिया है ना vertical distance. A fish rising vertically to the surface of water in a lake uniformly at 3 meters per second observes a kingfisher diving vertically downward, right, with the rate of 9 meters per second. Refractive index is given to you. So path should be taken as a straight line path only. So can I write down the relation like this? Now if you differentiate this equation with respect to time, you will be able to have here dh by dt is equal to dx by dt plus mu multiplied by dy by dt. What is y? Actual height hai ye. So you need to calculate this particular value. ये आपको निकालना है. Rest of the quantities are given to you. Rest of the quantities are given to you. So what is dH by dt? That is the 9 meter per second. So you can substitute here 9. The fish is moving upward with the speed of. So 9 is equal to 3 plus refractive index. Refract 4 by 3 multiplied by dy by dt. So you need to calculate only dy by dt. You will be able to get the answer for the given question. आ रहा है आंसर अभी कितना आ रहा है 4.5 हो गया कितना है आंसर 4.5 है ना 4.5 no it will not come 4.6 4.5 ही आएगा directly. Write down a question then. A bulb is placed at a depth of a bulb is placed at a depth of a bulb is placed at a depth of 2√7 meter in water and a floating opaque disc is placed over the bulb so that the bulb is not visible from the surface. What is the minimum diameter of the disc? What is the minimum diameter of the disc? Now, this is very important. When you are inside the water in a swimming pool, and if you are in a danger, and if you start flashing the light from inside the water, probably the men on the boundaries of the swimming tank, outside the swimming tank, will not be able to see the light. You cannot shout from inside the water because the sound will not be coming outside the water. So related to that, this problem has been given that there is a bulb at the bottom of that particular tank, and the top of that bulb at the top of the water is covered with a certain disc whose radius is to be determined. Think about it. Yesterday we have discussed the concept of total internal reflection. The problem is related to the total internal reflection. Should I start? So at what height or at what depth you are having the bulb present here? What is the height? This height is given to you as 2√7. 2√7 meter. Meter में दिया है ना? Okay. Now, you are aware of the fact if the ray of light starts from the center and moves to the top along this direction, it will be passing straight out. On the other hand, if you are having this as the angle of incidence, which we call it as critical angle, the ray will be traveling parallel to the surface here. Similarly, with the same critical angle, if it is coming onto this side, angle of incidence here is a critical angle. The ray will be traveling parallel to the surface. Angle of refraction will be 90 degree here, as well as angle of refraction will be 90 degree here. Right? But if you are having the angle of incidence greater than critical angle, what would happen? There will be a total internal reflection. Yani, at least up to this particular size, I should be able to have a disc floating on the surface of the water so that the angle of incidence, when it becomes greater than the critical angle, it will suffer the total internal reflection. So this disc, this is representing a disc whose diameter is to be calculated. So this is representing the radius of the disc. The height is given by h. For the critical angle, this has critical angle, this will be also the critical angle here. Now, yesterday we have seen that sine of critical angle will be equal to 1 upon refractive index of a denser medium with respect to the rarer. This is representing to you denser medium because the light is traveling from denser to the rarer here. Then only there will be a case of total internal reflection. Am I right or wrong? Right? Now, in this case, we have to find out the diameter. So, I use here that if I call it as angle of sine of I will be equal to opposite side, that is R, divided by, you are having the hypotenuse, that is under root of R square plus H square. Suppose this is angle of incidence here. So sine of I will be opposite side upon the hypotenuse. Right? My condition here is very clear that I should be greater than critical angle here. So sine of I should be greater than sine of critical angle. So sin I is taken as R upon under root of R square plus H square is greater than 1 upon refractive index mu. So I will be able to write down here mu into R is greater than under root of R square plus H square. Taking square of both the sides, you will be having mu square R square greater than R square plus H square. I am subtracting R square from both the sides, so you are having mu square minus 1 into R square greater than H square. So value of R square should be greater than H square divided by mu square minus of 1. Right? Now you can say here that the radius of the disc should be greater than h upon under root of mu square minus of 1. The value of h and mu are given to you. So this is the minimum radius required for the disc. Multiplied by 2, you will be able to get the diameter of the disc. So if such a disc is made floating on the surface of the water and at the bottom there is a bulb, the light will never emerge out of the water. Can you calculate the value now? Mu? Water का है ना problem 4/3. रेडियस कितना आया? रेडियस 36 है. Radius is 6. Radius is 6 meter and diameter will be 12 meter. Square root नहीं लिया था. आ गया आंसर या नहीं आया अभी तक? Done. Now just tell me how many problems we have covered today. 18 problems. And one formula I have added to the list today. Total magnification is a product of magnification of the two mirrors there. So total formulas are 85. 95 तक पहुंचे? Okay. And questions? Question now. Now you can imagine how big the topic is. Still, we have to go for prism. After prism, refraction at the curved surface. Then refraction due to the lenses, types of lenses. But types of lenses, you can do it very well on your own. The basic had been covered in a concave mirror as well as convex mirror. Concave mirror will be behaving, the concave mirror and the convex lens will be behaving similarly. You will be able to have a convex mirror and your concave lens, they will be behaving in a similar manner. The concepts are identical because there also we take the rays to be traveling from left to right. Only the thing is that the focus is on the other side. As there are two curvature, there will be two foci, two center of curvature, one optical center. We don't call it as a pole now. Pole was the extreme position there, but it is now to be taken as a optical center. So distances are measured from optical center. The concept remains the same. If you are measuring the distances in the direction of light, the distances will be taken as positive. If you are measuring the distances in the direction opposite to that of light, the distances will be taken as negative. So that is how the lenses would be there. After that, there is a combination of lenses. Like we have seen the combination of concave and convex mirror today, similarly, you will be having combination of lenses. And that leads to the last topic, and that is nothing but your microscope and telescope. Because in microscope also you are making the use of two lenses. Telescope also you are making the use of two convex lenses. So how that microscope and telescopes are made, it's about that part. That will complete the topic. So I will not be able to complete the whole topic as I have already told you in the initial part. But one thing I have done. The Maharashtra state government has recorded my lectures for the students. So I have made it available to all of you. The lecture link is with Sai Prasad sir. So you can take the link from it and see all the lectures except for work, energy, power. Because the two teachers were teaching at that place and that person didn't allow me to take that chapter twice. That is the only reason. But otherwise, all the chapters have been covered there. So you can refer to that and work on it. So you can have that particular microscope, telescope, everything that has been covered there. Link is available with Sai Prasad sir, so you can share with that and just go through it so that it will be benefiting to you. Another important thing, I'll be able to take some small portion of prism theory tomorrow so that we are able to cover some part. And after that, I would go for what I can say, some general discussion for the part of preparation of physics that could be there. You'll have a small test towards the end tomorrow. And that test is not going to be difficult. It is based on very simple things that we have already discussed in the classroom. I'm not going to put down any question which are not discussed here. Problems are literally, hardly you can say one or two problems are there. Rest of the questions are based on theory. It's objective test. Fill up the test part. See that you are looking at it. We have worked certain hours here. And out of that, how much you are able to get, retain, that particular part will be tested. So it's not a difficult one. You can take the time you want. There is no point in copying it because it's an individual approach. Because if you are individually getting it, then it's a benefit. This is not going to count in your marking system. That is only for the sake of creating a record that after teaching, how much you are able to understand. So all the tests of the JEE or the NEET type are based on objective questions, which are nothing but the problems. But there are hardly one or two problems out of 30 questions that are there. The 30 question की छोटा सा test है, वो दे दीजिए. So I will not be able to take the second part of it as we are doing it. After the lunch part, I will not be able to take it because I have to rush to the airport and do other activities also. or some part I will be there for half an hour, I will be there. But that is how we'll be meeting, and we'll be covering the part, whatever has been given to me. As much as I could complete it to a certain level. I know that level is very high, and I said it right in the beginning that this is the most difficult topic that has been given to me. I told you electrostatics is difficult to understand, easy to score. रे ऑप्टिक्स इज डिफिकल्ट टू अंडरस्टैंड एंड डिफिकल्ट टू स्कोर. एक छोटी सी गलती, माइनस साइन की एक गलती हो जाती है तो योर आंसर्स गोज रॉन्ग. Am I right or not? So that part is there. Okay? So I'll stop for today here and take some part of the prism theory. You will enjoy that particular part. Some mathematics will be again coming in. So that is a real trouble for those who don't have a study of mathematics to a greater extent. But physics means mathematics, that you have to keep it in mind. Okay? Thank you for bearing me to the great extent. Because to listen to a person for 6 hours a day, at least 5 days we have worked. Barabar hai na? So it's a huge amount of time. Thank you. Sai Ram.